This video contains a review of polynomial long division. There are two cases that we're going to consider. The first is where the numerator polynomial is of a higher degree than the denominator. The second case, the denominator polynomial is of a higher degree than the numerator. And this affects how we do the polynomial division. So let's do it. Let's see an example. Let's imagine that we have the polynomial x squared plus 3x plus 6, and we divide that by x plus 1. Okay, now because the numerator is of a higher degree polynomial than the denominator, when we write, it's x plus 1 divided by, I should probably clear that up, I have a nice eraser here, x plus 1 divided by, x squared plus 3x plus 6 divided by x plus 1. Okay, we write our polynomial in terms of decreasing x. Okay, the denominator and the numerator we write in terms of decreasing powers of x. So let's see how we do this. So x goes into x squared how many times? It goes in x times. X times x is x squared, and we subtract. Okay, but we have x times 1 is x. Okay, so we do the subtraction. So x squared minus x squared is 0. 3x minus x is 2x. Okay, and here we bring down the 6. Okay, so now we say, how many times does x go into 2x? Well, x goes into 2x 2 times. 2 times x is 2x. 2 times 1 is 2, and then we subtract. 2x minus 2x is 0. 6 minus 2 equals 4. So the result of x squared plus 3x plus 6 over x plus 1 is equal to, this is equivalent to, okay, x plus 2 with a remainder of 4 over x plus 1. Okay, so these two equations, they're equivalent. Okay, so this is polynomial long division, where the numerator is of a higher degree polynomial than the denominator. But what happens if the denominator is of a higher degree than the numerator? What happens in that case? And how do you evaluate something in that case? So let's see an example, and it's an example that we're interested in. Okay, for a number of reasons, but let's see this example here. I'm going to delete this one. Okay, and we're going to evaluate what is the result of, what is this equivalent to? 2, I believe I zoomed out. Try to zoom in again here. Getting used to this interface. Okay, all right, so 2 over 2 minus x. Okay, so how do we evaluate that? Well, that looks like this. Now notice the polynomial of the denominator is of a higher degree than that of the numerator. Okay, so we write it this time in terms of increasing x. Okay, increasing powers of x. So the numerator is 2, but it has 0x and 0x squared and 0x to the 3. Okay, this is a 0th power of x. This is a 1 power of x. If there was another one, we write. So we write the polynomials in terms of increasing powers of x here. Okay, so now let's do the evaluation, and we're going to see what this is equivalent. This function is equivalent to. So how do we do it? Well, 2 goes into 2 once. 1 times 2 is 2. 1 times negative x is negative x. and then we subtract. 2 minus 2 is 0. 0 minus minus x is x. Okay? So 0 minus minus x is x. So now, how many times does 2, remember it's in terms of increasing x, so we take the first one. How many times does 2 go into x? Well, 2 goes into x, same thing as x over 2. X over 2 times 2 gives us x. X over 2 times negative x is negative x over, negative x over x squared over 2. And here we can bring down the 0x squared, right? And then we subtract. Okay, so here we have x minus x is 0, and then 0 minus minus x squared becomes x squared, right, over 2. Okay, 2 goes into, right, x squared over 2. It goes in, how many times? It goes in x squared over 4. X squared over 4 times 2, right, equals, right, is equal to x squared over 2. And then x squared over 4 times negative x is equal to negative x to the 3 over 4. So when you subtract, and you can bring down the 0x to the 3 here. Okay, when you subtract, you end up with 0, and then you get 0 minus minus x is x to the 3 over 4. Okay, and the same thing happens. Now you can say, okay, 2 goes into x to the 3 over 4. It goes x to the 3 over 8, right? X to the 3 over 8 times 2 is x to the 3 over 4 minus x to the 3 over 8 minus times minus x is x to the 4 over, right, x to the 4 over 8. And then you can bring down the 0x to the 4 here and subtract. Left with 0 plus x to the 4 over 8. And basically what happens is that this series, in this long division, let me see if I can zoom out a little bit, it never ends, okay? So effectively, what you get is that 2 over 2 minus x is equivalent to 1 plus x over 2 plus x squared over 4 plus x to 3 over 8 plus dot, dot, dot. Okay, so this function, f of x, can be approximated, if you keep adding an infinite number of terms, by this polynomial. Okay, the more terms you add, the more accurate it's going to be. Okay, so this is how you do polynomial long division, but it also shows us that a function, right, a function can be approximated by a polynomial series, okay, or a power series. And this is the power series expansion.